You know, every time you post a photo, buy something online, or even just save a new contact to your phone, there's this entire universe of activity happening just behind the screen. Your information, your data, it's all being carefully managed. So today we're going to pull back that curtain and look at the fundamental rules that govern the life of every single piece of data in our digital world.
Creating a relationship is easy, but maintaining it is difficult. Now, you might think this is just some good old-fashioned life advice, but honestly, it perfectly captures the single biggest challenge in computer science. How do you keep millions, maybe even billions, of connected pieces of information in perfect logical order?
So in this explainer, we're going to break it all down. We'll start with the 4 basic actions you can take with data. Then, we'll see how different bits of data get connected. We'll uncover the secret handshake they use, called primary and foreign keys. Then we'll set some rules for those relationships. And finally, we'll see why this whole hidden structure matters so much in every app you use.
All right, let's dive right in. At its very heart, managing data really just comes down to 4 basic actions. These are the absolute fundamental building blocks for, well, everything.
To make this all feel a bit more real, let's use a simple example that we can follow all the way through. So on the left, we've got a table of students, and on the right, a table of their classes, or batches, as we'll call them. Just 2 simple, separate lists of information for now.
So what are the 4 actions? They are create, read, update, and delete. And in the programming world, this is known everywhere by the acronym CRUD. It's a really simple but powerful framework that describes the entire life cycle of any piece of data you can think of. Literally, every second of every day, billions and billions of these simple operations are powering our digital world.
First up, C is for create. This one's pretty much exactly what it sounds like. You're making something new. Let's say a new student enrolls in our school, so we create a new entry for them. A brand new row gets added to our student table. Nice and simple.
Next, we have R for re. Now, this is by far the most common action. It's anytime you just want to look at the data. Think of it like you're just asking a question, like, hey, show me all the students in batch A. You're not changing a thing, you're just looking it up. And believe me, making this one action happen almost instantly is a multi-billion-dollar industry all by itself.
Then there's U for update. This is for editing data that's already there. So let's say Jane Doe gets married and changes her last name. We don't create a whole new Jane, we just go into her existing record and update that one specific piece of information.
And finally, D is for delete. When a student graduates and isn't part of the school anymore, we can remove their record completely. This action is usually permanent. Poof! The row is gone from the table. So that's CRUD, the 4 basic operations.
But okay, here's where it starts to get really interesting. We've got our 4 actions, but we still have 2 totally separate tables, a list of students and a list of batches. And right now, they don't have a clue about each other, and that leads to a huge problem.
I mean, if you look at our students table, you'll see a column called batch ID. For John Doe, the value in that column is 1. So what does that mean? Is that batch A? Is it the very first batch ever created? We have no idea. Without a connection to our other table, it's just a number with no meaning. It's basically data chaos just waiting to happen.
The solution to this chaos is actually an incredibly elegant system. It's a way for these tables to form relationships using a kind of secret handshake. And it's all based on 2 key ideas, the primary key and the foreign key. First up, the primary key. Think of this as a column where every single value has to be unique. It's like a student ID number for each row. So in our batches table, the batch ID is the primary key. There can only be one batch 1, one batch 2, and so on. It's a guarantee of uniqueness, and that's what makes the data reliable.
Now for the other half of the handshake, the foreign key. A foreign key is a column in one table that points directly to the primary key in another table. It's the bridge, it's the link that creates the relationship, the line that connects the dots between our 2 separate lists.
And here we see it in action. The batch ID column in our students table is a foreign key. It is specifically designed to point to the batch ID primary key over in the batches table. So now, when we see batch ID 1 for John Doe, the system knows without a shadow of a doubt that 1 means batch A. Just like that, the relationship is formed. The chaos is gone.
So, we've created the relationship. That was the easy part. But remember our opening quote? The hard part is maintaining it. Now that our tables are linked, we have to decide what happens if something in one table is changed or, more importantly, deleted. We need to set some rules.
Let's ask a really critical question. We can see that Jim Brown and Jack Johnson are both in batch B, which has a batch ID of 2.
What if the school suddenly decides to cancel batch B, and we just delete it from our batches table? What should happen to Jim's and Jack's records? And this isn't really a technical question, it's a business decision that has technical consequences.
And this is where the business logic comes in. We've got a few options. We could set a cascade rule. With this one, deleting batch B automatically deletes Jim and Jack, too. It's kind of a clean sweep approach. You choose if the business decides students can't exist without a batch. Or we could choose set null. In this case, their batch ID just becomes empty. It keeps their records, but now they're students without a class, flagged for someone to reassign later. Or there's no action. With this rule, the system just stops you. It throws an error and says, nope, you can't do that. It's a safety lock, forcing you to move the students first before you can ever delete the batch.
So you might be thinking, okay, that's a lot of work. So why do we even bother with all this? Well, these keys and rules are basically the unsung heroes of our digital lives, constantly working behind the scenes to turn what could be total chaos into perfect, reliable order.
This whole system is about maintaining something called data integrity. And really, that's just a fancy term for digital trust. It's the reason you trust that your bank balance is correct, and it's why a business can trust its own sales figures. These rules prevent all sorts of bizarre situations, like having a student assigned to a batch that doesn't even exist anymore. It's the guardrail that separates a well-built, trustworthy app from a buggy, unreliable mess.
And you see the results of these kinds of business decisions every single day. When you delete your social media account, that's a cascade rule in action, for privacy reasons. It deletes all your content too. When a product is discontinued but it still shows up in your old order history, that's a no-action rule protecting that financial record. And when you untag yourself from a photo, well, that just updates one tiny relationship. It doesn't delete the photo itself, which shows you just how specific and powerful these connections can be.
So the next time you use an app, think about the data relationships that are being maintained. Every single time you delete a playlist or untag a friend from a post, you are triggering a rule that was a deliberate business choice. And now that you know what they are, can you guess not just what's happening, but why they designed it that way?